Hello students, in the last lecture some type of the voltaic cell we have studied, and that voltaic cell was the nickel cadmium cell and mercury cell. Today we are to study another one important type of galvanic cell or voltaic cell. It is fuel cell. So see what is fuel cell, and later we are to study in detail hydrogen, oxygen, fuel cell. Here see, fuel cell is a cell. It is a cell in which chemical energy in fuel is converted into electrical energy. Chemical energy in fuel is converted into electrical energy. So fuel used in this cell may be hydrogen, methanol, or other liquid hydrocarbons like the petrol or diesel. That is nothing but the fuel cell. Coal also. In thermal power plant, coal when burnt, then that energy which is released, that vapors are from water, त्याला वेपराइज केलं जातं ते बर्न करून कोल, and that water vapors are used to rotate the turbines and it generate the electricity. But what happens, that cell have very less efficiency, means conversion of chemical energy into electrical energy is very less in case of that thermal power plant. But what happens in fuel cell, the energy is transferred into electrical energy, its efficiency is high, that is 70% efficiency. So therefore these cells are more efficient than that of the other cells. Then here see, we are to study hydrogen oxygen fuel cell in detail. Hydrogen oxygen fuel cell. Hydrogen oxygen fuel cell, that is H2O2 fuel cell. H2O2 fuel cell. So in this hydrogen oxygen fuel cell, hydrogen is fuel. Hydrogen is used as fuel, and in this cell, hydrogen when reacted or treated with oxygen in this cell, then it generates electricity. That is nothing but the hydrogen burned actually in the presence of oxygen. When this reaction is take place in this well designed cell, that is the fuel cell, then electrical energy is generated, electrical energy is produced. So that is nothing but the H2O2 fuel cell. Now we are to study construction of fuel cell. So how this fuel cell is constructed, that we are to study. In the construction of fuel cell, here you see, this is the diagram of fuel cell. In this here, this is the long cylindrical vessel. In this cylindrical vessel, two graphite electrodes are used, that is this electrode, cylindrical electrode is used as anode, and this electrode is used as cathode. Now in this electrode, the catalyst like the platinum antimony are incorporated, they are used as catalyst to take place the reaction fast. Then here this pipe of hydrogen gas is fitted at anode and this pipe or inlet of oxygen gas is fitted at cathode, and these both electrodes are placed in hot solution of KOH, hot KOH solution, so that alkali is used as electrolyte here. In this cell, KOH solution or NaOH solution is used as electrolyte, and this is the outlet to remove the water. And when the reaction of hydrogen and oxygen takes place in this cell, then electricity is generated, electricity is produced. So that is we are to study now. This is C, porous carbon electrode incorporated with platinum, that is used as catalyst. That is the catalyst. Now we are see working of this cell. Working of this cell or cell represented in this way. What that is the platinum, carbon rod, platinum incorporated in it. Then what that is the hydrogen gas is bubbled at this electrode. Directly it is placed in aqueous hot solution of KOH. Here what that is the oxygen gas is platinum and carbon cathode. This is the carbon anode. In this way this cell is represented. Okay. Now see working of fuel cell, working of hydrogen oxygen fuel cell. So that we are to study. When hydrogen oxygen fuel cell is connected externally by means of metallic wire, here see, oxidation takes place at anode and reduction takes place at cathode. Oxidation, what to do, that is hydrogen gas is passed at anode and oxygen gas is passed at cathode. So one advantage of this cell, both the hydrogen and oxygen gas are supplied externally. Therefore we can supply it as long as, and therefore cell can run long time. This can continuously run for the long time. Like to that of the other cell, it does not stop its working because electrolyte is not finished and the gases which we are passing at that electrode are passing externally. आपण त्याला एक्सटर्नली फेड करतोय, त्याच्यामुळे ते जोपर्यंत आपण ते पास करू तोपर्यंत ती सेल कंटिन्यूअस वर्क करत राहील. सो हियर सी reaction taking place at anode. Hydrogen gas when passed at anode means when hydrogen gas is passed at this anode, this hydrogen gas reacts with the hydroxyl ions of alkali. तो अल्कलीच्या हायड्रॉक्सिल आयन्स बरोबर रिएक्ट होतो. It reacts with the hydroxyl ions of alkali. There is formation of water with the loss of 4 electron. This is the oxidation reaction. Oxidation takes place at anode. Hydrogen gas is passed at anode. Hydroxyl ions and that hydrogen gas react to produces water. Then reaction taking place at cathode. Reaction taking place at cathode. At cathode, reduction reaction is take place. At cathode, oxygen gas is passed, and this get absorbed on that platinum electrode, that is the carbon electrode, and then it reacts with what, that is the water. So here see, oxygen gas plus 2H2O accept 4 electrons and there is formation of 4 hydroxyl ions. This 4 hydroxyl ion again used at anode. Again it produces water and again here water, half of the water molecule again used at cathode. So this is the reduction reaction. Now see, oxidation takes place at anode, loss of 4 electron. Reduction takes place at cathode, gain of 4 electron. And now from these two half reactions, oxidation at anode and reduction at cathode, we have to write the net cell reaction, overall cell reaction. So overall cell reaction twice of H2 gas plus O2 gas, because this 4OH minus ion cancel, 2H2O and this 2H2O cancel, 2H2O remaining. This is the spontaneous redox reaction takes place, and EMF of the fuel cell, H2O2 fuel cell, is 1.23 volt. It is what? That is the 1.23 volt. That is nothing but the EMF of this cell, because potential developed at this electrode is 0.40 volt, and oxidation potential or reduction potential developed at this electrode is 0.83 volt, and therefore sum of these two gives the potential of cell. So cell potential of hydrogen oxygen fuel cell is 1.23 volt. It is 1.23 volt. This is nothing but the construction, representation and working of the H2O2 fuel cell. So hydrogen and oxygen reaction, if takes place in this well designed fuel cell, then electricity is generated, electricity is produced. Now some other points of this cell that we have to study, means what are the advantages of this cell. Advantages of this cell. Advantages of fuel cell. So advantages of fuel cell, that is fuel cell pollution free working. What that is the pollution free working? So there is no any gas produced which pollutes the air. There is no any substance formed which is harmful to us. While here there is formation of water, it is purest form of water that is directly used as ड्रिंकिंग पर्पस. ये जो पानी इसमें फॉर्म होता है, इस पानी का यूज हम डायरेक्टली ड्रिंकिंग पर्पस के लिए यूज कर सकते हैं, ड्रिंकिंग पर्पस के लिए यूज कर सकते हैं. सो हियर सी पोल्यूशन फ्री वर्किंग. देन सेकंड वन केस दैट इज हाई इफिशियंसी. इट हैज हाई इफिशियंसी. इफिशियंसी ऑफ दिस सेल इज 70%. म्हणजे 70% एनर्जी विच इज प्रेजेंट इन हाइड्रोजन गॅस is converted into electrical energy. It has 70% efficiency. Then next one advantage of this, it can continuously work. It can continuously work as long as we fed hydrogen and oxygen gases into that cell. हम जब तक हाइड्रोजन एंड ऑक्सीजन गैस उसमें पास कर सकते हैं, पास करते हैं, तब तक वो कंटिन्यूअसली वर्क कर सकती है. इट डज नॉट स्टॉप. दूसरे सेल का लिमिटेशन क्या है? वो इलेक्ट्रोलाइट अंदर होते हैं और वो इलेक्ट्रोलाइट खत्म होने के बाद वो सेल स्टॉप हो जाती है, वर्किंग ऑफ सेल स्टॉप, पोटेंशियल ड्रॉप्स टू जीरो. ये सेल में ऐसा नहीं होता. इस सेल में, ये जो सेल है, इसमें हाइड्रोजन एंड ऑक्सीजन गैसेस हम बाहर से अंदर पास करते हैं. तो बाहर से अंदर पास करने के लिए कोई लिमिटेशन नहीं है. हम कितनी भी देर तक, जितनी देर तक हम पास कर सकते हैं, उतनी देर तक ये सेल वर्क करती है. यानी कि दिस सेल कंटिन्यूअसली वर्क फॉर लॉन्ग टाइम as long as we fed the gases into that cell. That is nothing but the advantages or advantage of the cell. Pollution free working, high efficiency, and it can be continuously work for the long time. The water which is formed in this cell or during the cell reaction, that is pure and it can be used for the drinking purpose. This is nothing but, or these are the advantages. Now see the applications of hydrogen oxygen fuel cell. It was used in अपोलो मून स्पेस मध्ये या सेलचा यूज केला. अँड अपोलो मून स्पेस मध्ये यूज केल्याच्या नंतर that is used as a power, electric power, and water which is formed, astronauts use that water for drinking purpose. Astronauts use that water for drinking purpose. That is nothing but one of the important application. Second one, that is this cell H2O2 fuel cell is used on trial basis in self-start automobile to generate the electricity as a electric supply, as a power supply. It is used on trial basis in self-start automobile. It is the best source of electric energy in future. यानी क्या भविष्य में ये एक बेस्ट इलेक्ट्रिक एनर्जी का सोर्स हो सकती है दिस सेल, दैट इज H2O2 fuel cell. So this is about the fuel cell. Now see one more point in this chapter here remaining, and that we have to study, that is nothing but the electrochemical series. Electrochemical series or EMF series we have to study. Electrochemical series or EMF series. What is electrochemical series? We have to study applications of electrochemical series in detail. So in that electrochemical series, what are the applications or what are the uses given, that also we have to study. Here see now in electrochemical series. Electrochemical series. Now in electrochemical series, elements in their electrode form are arranged in the decreasing order of their standard reduction potential, and that series is called as the EMF series, or it is also called as electrochemical series, electromotive force series. Electrochemical series or electromotive force series, or which is also called as EMF series. This is also called as EMF series. Now see some key points in this electrochemical series. Here we are to study. Can you see fluorine is placed at the top of this EMF series. How will you write the fluorine electrode, that is the platinum? Around this platinum, fluorine gas is bubbled around this platinum, and it is in contact with the fluoride ion like this. And what that is the इलेक्ट्रोड पोटेंशियल ऑफ EMF सीरीज में इसका जो इलेक्ट्रोड पोटेंशियल है फ्लोरीन का, दैट इज 2 पॉइंट, its standard electrode potential is 2.85 volt, which is positive. 2.85 volt, which is positive electrode potential. Now what happens, the element, that electrodes are arranged in decreasing order of their standard reduction potential value. So उसके बाद फ्लोरीन के बाद कौन सा एलिमेंट है, that is the gold. Here what, that is the Au. Then here chlorine is there. Before it what, that is the oxygen is also there, that is the O2. Oxygen is here, oxygen, gold, chlorine, as well as some of the elements like the what, that is the platinum, then here what that is the bromine, then mercury, here Hg, then what that is the copper, then here silver, and here what that is the hydrogen, whose potential is 0.00 volt, means the 0 volt. Below to hydrogen there is lead, then here antimony, then nickel is there, then here cobalt, cadmium, also what that is the iron, Fe, chromium, then zinc, aluminium, magnesium, sodium, then calcium, potassium and lithium. The standard reduction potential value of lithium is minus 3.045 volt. It is minus 3.045 volt. Some of the element I would like to tell you, that is the 0.80 volt. Copper is what, that is the 0.34 volt, like this. Then what, that is the zinc, minus 0.76 volt, or another some element like the what, that is the iron, minus 0.44 volt. It is iron, it is what, that is the minus 0.44 volt. And in this way, these are nothing but the elements in EMF series above hydrogen have positive standard reduction potential. It has positive standard reduction potential. The element which are placed below to hydrogen have negative standard reduction potential value. So this is the EMF series. You see in your textbook, in this chapter at the last page, one series is given. You see that series, all the element in the form of electrode, as well as electrode half reaction is given also there. Electrode half reaction means what? Suppose here zinc 2 plus ion accept 2 electron gives the zinc. So all these reduction potential, so reactions given also, reduction half cell reactions. Reduction half cell reactions are given, and that here we have to study. For example, what that is the F2 accept 2 electron gives 2 fluoride ion. Reduction potential of chlorine is highest in this series, 2.85 volt, and reduction potential of lithium lowest in this series, which is placed at the bottom. It is placed at the top of this EMF series. So this series in which the elements are arranged in the decreasing order of standard reduction potential value decreases. Standard reduction potential value decreases in this manner. So this series is called as electrochemical series or EMF series. Okay. Now see, we have to study applications of EMF series. Applications of EMF series. So what are the applications of EMF series that we have to study? First one application of EMF series is what, that is the relative strength, to decide the relative strength of oxidizing agent. Relative strength of oxidizing agent is decided from this. So how will you decide the relative strength of oxidizing agent? That we have to study. Here see once again, I am actually arranging like this. That is, let's see, applications of EMF series. Applications of EMF series. So EMF सीरीज के एप्लीकेशन क्या है, उसके फायदे क्या है, उसका यूज क्या है, so that we have to study. First one application to decide relative strength of oxidizing agent. Relative strength of oxidizing agent is decided from the EMF series. So how it is decided? In this series, the elements which are placed at the top of series, at the top of series, they have highest positive standard reduction potential. They have higher positive standard reduction potential value, and therefore they have tendency to undergo the reduction fastly. Hence, they are acts as oxidizing agent. They are act as oxidizing agent. So you don't forget that elements which are placed above hydrogen, which are placed at the top of this series, they have higher or highest positive standard reduction potential value, and therefore what happens due to highest standard potential value, they have tendency to undergo the reduction, and therefore they are act as oxidizing agent. They are act as what? That is the oxidizing agent. Therefore fluorine, then chlorine, oxygen, bromine, as well as copper, they are act as oxidizing agent. म्हणजे here reducing power increases down the group and oxidizing power decreases down the group. See, second one application, relative strength of reducing agent. So relative strength of reducing agent, element which are placed at the bottom of EMF series, that element have highest what, that is the negative value of standard reduction potential. हाईएस्ट निगेटिव वैल्यू ऑफ स्टैंडर्ड रिडक्शन पोटेंशियल यानी कि इस एलिमेंट में रिडक्शन की क्षमता नहीं है, यानी कि खुद रिडक्शन नहीं होता इनका, ये दूसरों का रिडक्शन करते हैं, यानी कि दे आर इजीली अंडरगोज ऑक्सीडेशन, एंड देयरफॉर दे आर एक्ट्स एज strong reducing agent, or they are act as reducing agents. These elements are acts as reducing agent. So element which have highest negative value of standard reduction potential, they have tendency to undergo the oxidation fastly, and therefore they are act as reducing agent. Therefore element which are placed at the bottom of this series, so lithium is strong reducing agent, and other elements also like the sodium, potassium, magnesium, aluminium, calcium, the element which are placed below 2 hydrogen in this series, which are placed below 2 hydrogen, they are reducing agent, and which are placed at the bottom like lithium, potassium, sodium, magnesium, calcium, they have highest value of standard reduction potential value, that is negative, so they readily undergoes oxidation, they easily undergoes oxidation, and they are act as strong reducing agent. So you have to remember, as we move down this series, reducing power increases and oxidizing power decreases. And if we move up, then oxidizing power increases and reducing power decreases. That is nothing but the relative strength of oxidizing and reducing agent decided from this series. Then see, next one application of what, that is this series, that is nothing but the spontaneity of redox reaction, to decide the spontaneity of redox reaction. So spontaneity of redox reaction is decided from this, what that is the EMF series. How you decide? You have to find out the cell potential. Cell potential is reduction potential taking place at cathode minus reduction potential taking place at anode. म्हणजे reduction potential taking place at left electrode minus reduction potential taking place at right electrode minus left electrode. And if this standard reduction potential value is negative, then spontaneous redox reactions takes place. Spontaneous redox reactions take place. If standard reduction potential is positive, then what that is the non-spontaneous redox reactions take place. Don't forget that. From the given values of electrode, that is standard reduction potential of the cathode and anode, we have to find out standard reduction potential. From the standard reduction potential value, if it is negative, then spontaneous redox reactions may to take place, and if it is positive, non-spontaneous redox reactions take place. So spontaneity of redox reaction can be determined from the EMF series or electrochemical series. Now see the next one application, that is the displacement, to study the reactivity, to study activity of metal, activity of metal means it is studied from displacement reaction. So from displacement reaction, how will you decide the given metal is active or inactive or less reactive? So here you have to remember the metal with lower value of standard reduction potential displaces to the metal or element with higher value of standard reduction potential. यानी कि जिसकी वैल्यू कम है स्टैंडर्ड रिडक्शन पोटेंशियल की, जिसकी वैल्यू कम है वो उससे ज्यादा रिडक्शन पोटेंशियल वैल्यू जिसकी है उसको डिस्प्लेस करता है सॉल्यूशन से. फॉर एग्जांपल यू सी व्हाट दैट इज द zinc metal displaces to copper. Here see CuSO4 aqueous solution, and here there is formation of zinc sulfate aqueous and copper get displaced. This is the displacement reaction. इसमें क्या होता है, जिंक सल्फेट सॉल्यूशन फॉर्म हुआ और कॉपर को उसने क्या किया, डिस्प्लेस किया, कॉपर को डिस्प्लेस किया. और यू सी दिस रिएक्शन Fe plus CuSO4, it gives FeSO4, and what that is the copper displaced. यानी कि इस रिएक्शन में जिंक कॉपर को डिस्प्लेस करता है क्योंकि जिंक का रिडक्शन पोटेंशियल कॉपर से कम है. आयरन का रिडक्शन पोटेंशियल कॉपर से कम है. इधर देखो आप, आयरन, यहाँ है कॉपर, यहाँ है कॉपर. सो दिस इज नथिंग बट व्हाट दैट इज, यू मेक दिस वन व्हाट दैट इज द करेक्शन, दैट इज सिल्वर का ज्यादा है 0.80 और कॉपर का कम है 0.34. Therefore, silver displaces copper from copper displaces silver from silver nitrate solution. You see this reaction, that is the copper nitrate is formed and silver is displaced at their take. So if you place the silver nitrate solution in copper vessel, then why it makes blue? Because copper vessel में से copper silver nitrate में जाता है as a copper plus 2 ion, and copper plus 2 ion have blue color. So to study the activity of metal or displacement reaction, the metal which are were placed in this EMF series that displaces to all other element which are placed above it. यानी क्या, जिस एलिमेंट का, जिस मेटल का स्टैंडर्ड डिडक्शन पोटेंशियल कम है, वो उससे ज्यादा स्टैंडर्ड डिडक्शन पोटेंशियल वाले एलिमेंट्स को, मेटल को सॉल्यूशन से डिस्प्लेस कर सकता है और करता है. सो जिंक डिस्प्लेसेस कॉपर फ्रॉम कॉपर सल्फेट सॉल्यूशन, iron displaces copper from copper sulfate solution, copper displaces silver from silver nitrate solution, and solution becomes what, that is the blue color. So these are nothing but the applications of EMF series, applications of what, that is the EMF series. So therefore here this is about the electrochemical series or the EMF series, and all the points included in this chapter, that is electrochemistry, are finished here. Thank you.